Hi, I'm Alejandro Martinez. I'm going to be doing problem 5.1. In this problem, it says a particle of charge Q enters a region of uniform magnetic field B pointing into the page, and this field deflects the particle a distance d above the original line of flight. And the first part of the question is if this charge is positive or negative. So going ahead and start this problem, it gives us that B going into the page as shown here, and this is V. So with that, we're going to go ahead and do V cross B. They are both vectors. And then this is going to give us another direction, and it's going to be going upward. So using right-hand rule, we have going to the right, going into the page, going to give us upward. So the cross product of this, the vector field, will be upward. And we know that if it's going upward, it's going to be positive. So the problem is asking for the charge. So charge Q would be positive. It's going upward. First part of the problem. Let me keep reading. Second part. In terms of A, D, B, and Q, find the momentum of the particle. All right, so momentum equation. It's going to be P equals Q, B, R. Q we know is positive, we just found, so we can go ahead and solve for the momentum. Easiest way to do that is to solve for R. In our case, we're going to use Pythagoras' theorem. So on 5.1, I describe a triangle to do Pythagoras' theorem for. So I'm going to go ahead and just explain where I'm getting this triangle from. So to do Pythagoras' theorem, we need a right triangle. And in this case, we know our bottom one is A, and our hypotenuse is going to be R. So now for the left one, it's a little more complicated because it's skewed out. It went up to a height of D. So we know that it did add a little bit extra in our case because it's not a perfect right triangle over here in the drawing. So it knows a little bit extra. And that is our distance D that we have over here. But we know this total is R. Oh, my bad. This is our distance. So using that, we're able to do the Pythagoras theorem that I set up of R minus D squared, because we have to subtract this D from this R to get this distance. And then plus A squared, and that's equal to R squared. Oh, wait, that, not there. On the outside. There we go. And then from here, I continue on the problem. I just wanted to explain how we got the triangle right here. Thank you. So A squared plus B squared equals C squared. We have our A right there, the lowercase A squared. And C squared is actually going to be capital R. So capital R squared. Now, our B is a little more complicated. So our B is actually going to be our capital R minus the D distance, this guy over here. And that's going to be our B value for this problem. So plus R minus D. Because the D distance, as said in the problem, it's the distance after the particle has been deflected from the original line of flight. So we have to subtract that. Oh, and squared. Okay. I'm going to go ahead and do the FOIL of R minus D over here, and then I'll go ahead and plug it back in the problem just so I can show this step of math. So R minus D squared turns into this, R squared minus 2RD, and then we're going to have plus D squared, and we can go ahead and plug that one back in. So A squared plus R squared minus 2RD plus D squared is equal to R squared. Now, if we subtract over the R squared, these are going to cancel out. Giving us A squared minus 2RD plus D squared is equal to 0. We can go ahead and move the 2RD over to the other side because we're trying to find R in this case. So then we're left on the left with A squared plus D squared, and then on this side a positive 2RD. So once again, like I just said, we are trying to solve for R. So pulling the 2D on this side, We can go ahead and do that, giving us r by itself. R is equal to a squared plus d squared over 2d. Let me double check my notes. Perfect. And we can go ahead and plug that into this original equation. I'll write it again. So we could find the momentum of the particle. P equal to Q B R. R we can plug in. So P equal to Q. That looks like an A. Q B, and our Q is positive as we found in the first part. Q B A squared plus D squared over 2D. So in this question, given this region, we are asked to find if the charge is positive or negative. Doing the cross product of the two vectors, we find that it's upward, giving us a positive charge. And then it asks us to find the momentum of the particle. Using this equation, a little bit of Pythagoras' theorem, we are able to find that our momentum is equal to this right here. Thank you.